Okay, and up next we have Andrew. Andrew, someone or other. He can pronounce that himself. Who's going to be speaking about building a simple recursive art language in Racket. Racket is a really cool language. It sounds like a fascinating talk.
Maybe. We'll see. So, for those wondering, we pronounce it Gwozdziewycz. It doesn't make any sense. Don't know what to tell you. I have a friend named Chris Coyne. He wrote a little art language called CFDG a while ago, and I decided to implement it in Racket a little while ago. So as an example, we have this little program. This little program defines a rule called 4 circles. It draws 4 circles, then it recurses with a bunch of parameters, which we'll get to in a second. This is the same thing right now in Racket that my little interpreter can deal with. And it generates this little picture here. So it does that using these 4 primitive functions. Circle, which is the only one that's used here. Square, rectangle, which is kind of a relic of the past and a weird thing, but I kept it for historic reasons. And those parameters manipulate these registers, and these registers control different color orientation, the size of different things, and then importantly, the nesting level. How many times can you recurse? And so I've maybe been poorly implementing it. I don't know, we'll see. But every time I think about recursion, I think of sticky jelly stains on my hands from reading this book. And I figure building something that's recursive by default, by nature, maybe Scheme, Racket would be an interesting thing to play with to do this. And of course, those primitive functions are just Racket functions that know how to manipulate graphics. And that's it. So where do I draw a circle? We have these registers. There was an X, Y. Well, really what those registers are doing is they're setting up parameters to do affine transforms. So there was an R for rotation. The X, Y are sort of a translation unit. And so when we do something like circle x5, s0 dot point, or 0.75, what we're really doing is we're saying take these current parameters, the current x parameter, add 5 to it, take the scale parameter, multiply it by 0.75. And when we set these parameters, depending on the actual register, they get changed in a different way. So in this case, s multiplies, x adds. So there were 2 syntactic constructs, actually 3 syntactic constructs that we saw before. The first one, you don't have to worry about the code. It's there just because it looked blank otherwise. But there's start rule. Start rule, what it does is it's kind of the main program, the main part of the program. And it expands, macro expands into something that will set up a graphics context and set up some parameters that the primitive functions will use to draw a circle or a square or whatever. And then it actually just runs the function that was defined for it. And so then there's this rule construct. Rule is a little bit different. It's a little bit more complicated because I'm kind of lying to you. So that first 4 circles rule, if I had defined a second 4 circles rule, what would happen is the implementation would pick one at random. And I could actually assign weights to it. So I could say this one should run 10% of the time, this one should run 30% of the time, or whatever. So this is probably the most complicated thing of implementing this. And all it does is, probabilistically pull stuff out of a hash table. So that's great, but all I've done is defined a few macros and defined a few primitive functions. How do I turn this actually into a language? Well, let's do something. So in Racket, there's this concept of pound lang, and pound lang will say, okay, when I import this module, run it with this code, or run this sort of module. And if I do this, I define rule diamond, all it does is draw 8 squares with different parameters, like I said before. Start rule diamond, run it with racket diamond .rxt or rkt. I get this little thing, and that's kind of cool. So what's happening? Well, the CFDG language.rkt redefines module begin, which is exactly what happens when when a module is run with that lang construct there. And that s- expression thing was just use the s expression parser. So module begin in CFDG language basically just sets up parameters for the environment, the registers, and a canvas allocates all that sort of stuff. And if I really wanted to go back to the original slide, so I guess like slide 1 where there was like a curly brace syntax, Racket gives me the ability to do that by also defining how modules should be read. I can basically say pound::read and pound::read syntax, give those functions. Those functions could be constructed from say the parser tools library from Racket, which implements basically Lex and Yak, and all of a sudden I have like any ability to create a language, but I've got the ability to build all of the semantics of the language in a separate place, call it, debug it, test it individually, and then throw a syntax on top of it. Thanks. Hopefully you'll play around with Racket.